Bruker's NPFLEX-LA 3D surface metrology system for lead angle is the first comprehensive, non-contact metrology solution that repeatably quantifies lead angle and surface texture of dynamic sealing surfaces. There are over 80 dynamic stressed seals in a car, any of which can fail and leak fluid. It is estimated that the cost due to leaking seals runs in the tens of millions of dollars per year, not including recall costs, which typically can cost the automotive industry upward of $50 million per event. Tighter emissions standards, coupled with extended vehicle warranties, increases the need for higher quality and longer-lasting sealing systems. The shaft seal interface has a synergistic relationship, relying on the equilibrium of a fine lubricant film between seal and shaft. In addition to the surface roughness, the machining finish on the shaft is a critical factor for reaching equilibrium and achieving good performance. During the machining process, fine grooves are inadvertently machined into the shaft. These grooves, helical in nature, are potential areas of leakage. Following Archimedes' principle, the presence of a positive thread moves lubricant in the direction of the source, causing the seal to dry out, while a negative lead pulls lubricant away from the seal, causing the seal to leak. Periodic thread on the shaft is called macrolead, while a non-periodic helical pattern is denoted as microlead. Macro and microlead both contribute to the overall leakage profile of a shaft seal interface. To drive high-integrity sealing surfaces into the precision machining market, the Rubber Manufacturers Association of America, RMA, and International Standards Organization, ISO, have established standards for dynamic sealing systems. Both standards specify 0-degree lead on the shafts, which has been difficult to machine precisely and even more difficult to accurately measure.
I've been in this industry, the oil seal industry, for approximately 50 years. And during most of this period of time, we've used a string test method for measuring shaft lead. Now, shaft lead is very important to radial lip seal performance. This type of string test is very technique dependent. And in many locations, only one technician is allowed to run this test. And the other important thing is that if a customer is measuring a string lead measurement, and the supplier is measuring a lead measurement, there is very likely going to be a difference between the two readings because of its technique sensitivity. So what we do is we run this string on the shaft, and you can see it's traveling for a specified number of rotations. Now that's 21 rotations on the shaft. And so by taking the pair of verniers and measuring the distance that the string traveled from that pointer to the finish, and I've got there 300 thousandths, and I've gone like 21 rotations. So that means that you take 300 thousandths, divide that by 21, and you get the amount of travel that string went in one rotation. Then you take that amount, say 5 thousandths, and divide it by the circumference of the shaft, and that gives you the tangent of the angle. Then you can calculate the angle whose tangent is that number.
Although this string method has been the industry standard for over a decade, it has widely known disadvantages and failings. It has proven to be qualitative rather than quantitative because the results can vary from operator to operator and depend heavily on the level and wobble of the shaft at setup, as well as the surface finish of the shaft during measurement. The precision machining community is currently underserved in metrology for the measurement of surface roughness and, more importantly, lead angle of a dynamic shaft seal interface. To solve the uncertainty issues surrounding the measurement of lead angle and surface roughness on dynamically stressed sealing surfaces, Bruker has developed the NPFLEX with lead angle NPFLEX-LA. The NPFLEX-LA is the first 3D metrology instrument to provide repeatable and reproducible measurements for lead angle as well as surface roughness parameters outlined in the ISO and RMA standards. With patent-pending algorithms and method for calculating lead angle, the NPFLEX-LA provides accurate measurements without concern for part alignment and level. Taking advantage of Bruker's patented optical technology, the NPFLEX-LA utilizes the latest advances in white light interferometry to provide meaningful, accurate, quantifiable characterization of the sealing surface. With an industrial 3-jaw chuck, the setup routine is as simple as mounting the shaft or bearing, focusing the objective, and selecting a measurement routine from the setup guide on the user interface. During a single measurement routine, NPFLEX-LA calculates the radius of the cylinder and the angular power spectral density, or PSD, with respect to a common reference at each location along the shaft. This self-referencing method removes the influences of camera, stage, chuck, and part alignment from the calculation, reports global lead angle and both standard surface textures, RA, RZ, RPM, as well as the corresponding 3D parameters, SA, SZ, and SPM. The NPFLEX-LA features an easy-to-use production interface that provides reliable global lead angle measurements for QA and QC environments. A dedicated wizard walks operators through setup and measurement, generates customized reports, and uses pass-fail criteria to locate and discard nicks, burrs, and scratches on the measured surface.
This piece of equipment is going to be exciting for the industry for several reasons. One is that it has the basic parameters that you need if you're going to evaluate shafts for radial lip seals, but it also has some additional capabilities that can be added in for your individual requirements. So I'm really excited about this technique, and I think it's going to take off really well in the industry.
Learn more about how the NPFLEX-LA 3D surface metrology system for lead angle can provide you with quantifiable and repeatable lead angle and surface roughness measurements. Contact Bruker at www.bruker-axs.com or call 800-366-9956.